Hello guys, I welcome you to my channel. In my previous video we saw how we can conduct correlation analysis following Carl Pearson's assertion, following Morris Kendall Pearson correlation style, or using Charles Spearman correlation assertion. So in this video we are actually going to run the analysis using these variables you are seeing on my screen, and then following this particular research topic. For example, that's the effect of renewable energy on sustainable development, a case study of Ghana. So using this research topic as an example, we are going to run this test to get a correlation table or values that we can use to detect the strength of association, the nature of association, and then even the significance of the values that we get, or the significance of the correlation between the predictor variable and then the endogenous variable. So before conducting the analysis or before running the test, let's try to understand what's the meaning of correlation, because we will probably get, since we have not computed these values, we'll get a table indicating or illustrating or displaying all kinds of values that we need to make meaning of. So we'll get something we can simply call correlation matrix. So what's the meaning of correlation matrix? Correlation matrix is simply a table that illustrates the correlation or connection between multiple variables in a data set. Good. So having explained what's the meaning of correlation matrix, let's go ahead and then run the analysis to get values that we can use to explain the correlations between the variables. Okay, so first of all, what you have to do is go to analyze and then head on to correlate and then look for bivariates. A dialog box will appear in showing you all the various variables that you have in your data set. So we will start selecting them 1, 2, 3, 4 up to the last. We can actually highlight all of them and then exclude the demographic variable, since we will not need that one. So we're going to exclude education, employment, age, gender will be out of it, and then we move them to this side, and then you see the dialog box or the software has already set, or it's on default. Pearson correlations on default, but you can actually use, if any of them can give you the values or can let you know the correlation between your variables. So let's, as I said, let's start with the Pearson correlation. Good. Now down here you can find one tail, and you can also see two tail. What does it mean? You can actually select any of them, but what the two here means is that in case you are selecting between either one tail or two tail test, it actually depends on the research question and the hypothesis that you've formulated or that you've developed. Okay, so if one test, I would say one test is good for detecting impact in one direction, as in whether positive direction or negative direction, whilst two-tail tests are more conservative and more appropriate when the direction is highly uncertain. Okay, so in this research, for instance, it is highly uncertain. We don't know where the direction will be, whether it's going to be positive direction or whether it's going to be negative direction. So let's proceed. So we'll select the two-tail, for instance, and we'll continue with copy. So this is the table I was telling you, or this is the matrix I was initially saying. Okay, so if you get a table, a matrix like this, you get lots of, because of the variables that we have lots of variables here. That is, the variables here represent the questions we ask under each construct in our research questions or in our questionnaires. So you can actually copy this particular, you right click and then you copy. and then you head on to Microsoft Excel. Microsoft Excel, and then you paste the matrix or the table here. Okay, so in the table you can actually find that it starts with the first indicator or the first question asked under constructs, which is renewable energy. That is RE1, and then that is on the vertical side you can find RE1, and then on the horizontal line, that's the first line, you can also find RE1 up to SD10. Now let's go to the last side. At the vertical side you can also find SD10 at the same time. Now in my previous video I explained the meaning of the significance of values of 0.1 at 2-tailed, and then 0. in case you want 0.05, but this software, the spss software, normally uses the 0.01 as the significance value. So what it means is that if the values, in case you want to find out the correlation, if the correlation between a variable is significant or not, we'll use a benchmark value of 0.01. The software has actually used a benchmark value of 0.01, meaning all the values, or all the values that are greater than 0.01 are insignificant, and so the values that are good, as I said, it has used both 0.01 and 0.05. so meaning the values that are 0.0 are less than 0.01 are significant, or values that are less than 0.05 are significant. Good. I also explained the strengths, whether you get a weak correlation between the variables in my previous video. When you're going to get a weak correlation, and if in case you do get a weak correlation, a moderate correlation, or a strong correlation, what we use in detecting? We actually use a benchmark value of 0.01 to signify or to illustrate whether the correlation between the endogenous variable and the exogenous variables are weak. And then we also use a benchmark value of between 0.03 and 0.07 to indicate whether the correlation between the independent and dependent variables are moderate. And then the last one, we also use a benchmark value of 0.07 to 0.07 to 1 to indicate whether the correlation or the relationship between the predictor variables and then the outcome variables are strong. Okay, so as you can see from my screen, you see from RE1 diagonal side where I have highlighted yellow up to, if you follow that clearly, you could see that there's one in the diagonal shape in separating the upper part from the lower parts, as I indicated the first one with yellow. So as you can see from my screen, I'm trying to indicate all the ones with yellow. What this one is telling us is that all the values at the upper parts are the same as the values that we see at the lower parts. So the one in the diagonal line or diagonal, the ones, the figure labels 1 in the diagonal line is clearly separating the upper part from the lower parts, because the values we see at the upper parts are actually the same values at the lower parts. So if you get a matrix or a table like this, you can actually delete the upper parts since they are the same values at the lower side. Good. So you can actually follow the process that I'm using. Get rid of the upper values from the lower values since they are the same values that are on the other side. So we can start from this side, and then here the n here the n you are seeing in the values or in the matrix represent the number of respondents or the number of participants who actually or who successfully filled the questionnaire. And then the software actually use two-tail. I've already explained the meaning of the two-tail. And then the style or the Pearson correlation style it's used is Pearson's Pearson correlation. So that's the one showing here. So you can actually delete this side. The values here, you can actually delete them because they are the same values. If you bring them back, you can see that you could see clearly where I'm indicating green, light green. You can see that 0.742 it is the same 0.742 you will see here. That's the significance is showing 0.00, so it means that R2 the R2 and then its corresponding dependent variable, the relationship between them or the correlation between them is significant. That's how come it's showing 0.000, which is less than 0.01 and at the same time less than 0.05. So since they are same values here, I've already explained, you can delete them. Good. Now let's make this place white. Good. Now we can do the same thing for the remaining side and then delete them as well, since they are the same values there. Even if you are using it for your research work, there's no need showing the n, there's no need showing Pearson correlation here. It will make your table become big, or it will contain or consume much space. So we can delete the remaining ones as well. Good. Now you do the same till you get rid of all the values here. Since these values are not needed, you have to make sure you delete them because it's the same values. You don't have to present all these values if you are using it in your research work, or if you want to publish, if you want to use it, if you want to use this analysis in your paper that you want to publish. There's no need showing both values because they are the same thing represented at the lower side. Good. So you have to make sure you delete them. Good. Now I'm done deleting the upper values. Okay, so now if you want to present it in your research work, you can now you can see that it's from RE1 up to 10 and then SD1 up to 10. Since the A4 sheets cannot contain, that's the length of from this side to this side. If your A4 sheets cannot contain all of it, but it's necessary if you want to present it, you can present it actually, or there's a way you can also compute them for it to represent all the indicators, for it to represent one construct. It's another video I will do to show you how you can compute it. But if you still want to present it this way, you can also do it by actually cutting this side by actually cutting this side and then bring it down. So you can see that I have deleted the upper parts, and then make sure the all the repeated values are deleted, that is, which was mostly at the upper part of the matrix. So I've deleted them, so now you don't have to present it with the yellow, with the place highlighted yellow parts from it. And then you can also delete the one showing the number of respondents, which is 185. You can delete it from the matrix because it's not needed. Good. So now we can delete the number of respondents, which is showing 185, from the matrix because that place is not necessary. In case you want to present this matrix in your research or in your paper that you want to publish, there's no need showing that part. So since you can say this in your presentation or in your write-ups, that the number of respondents who successfully filled the questionnaire were 185. There's no point or there's no need showing it in the matrix. So you have to go ahead and then delete them from it. So from the matrix, what it clearly illustrates is that all the values that are less than 0.3 indicates a weak correlation between the variables, and then the values that are from 0.3 to 0.7 signifies or indicates a moderate correlation between the dependent and independent variable, and then the values that are from 0.7 to 0.7 to 1 illustrates a strong correlation between the predictor and then the outcome variables. So guys, this is how you can edit after getting your matrix from SPSS, after running the SPSS and then getting the matrix, the correlation matrix. This is how you can edit it, your matrix presentable in your research or in your paper that you want to publish it. Let's delete this one too, since it's not needed. That is the number of respondents. So we have been able to delete all the N, which it signifies the number of respondents or the number of participants from the matrix. So guys, this is a simple way, or this is a simple procedure you can follow to get your correlation matrix. If you find this video helpful, you can subscribe, you can like this video. Thank you for watching my video.